complex numbers. First example, find modulus and argument, principal argument of complex number 1, complex number z is equal to minus square root 3 plus I. So we know that if z is equal to x plus iy, then modulus of z is equal to square root of x square plus y square. So in this example, the real part of z is equal to minus square root 3 and imaginary part is equal to 1, and therefore mod of z is equal to square root of minus square root 3 square plus 1 square. So this is equal to, this is square, this is 3 plus 1 is equal to square root 4, which is equal to 2. So modulus of z is equal to 2. Next, the argument of z is equal to tan inverse of, now this complex number lie in the x is negative and y is positive, so it lie in second quadrant. So here the argument of z, principal argument, is equal to pi minus tan inverse of mod of y by x. So it is equal to pi minus tan inverse of mod of y by x, that is y is what? Here y is 1 and x is minus square root of 3. So this is 1 by root 3, which is equal to pi minus pi by 6. So 6 pi minus pi, it is equal to 5 pi by 6, and therefore this is the principal argument of the given complex number. It is also denoted by capital RZ, and the general argument can be obtained by adding here the general argument of z is equal to 5 pi by 6 plus 2k pi, where k is equal to 0 plus or minus 1 and so on, plus or minus 2, so on. So this is what the general argument, and this is what principal argument. Here we want to determine just principal argument. So answer is what? 5 pi by 6, and the modulus of z is equal to what? 2. The next example number same, we want to determine modulus and argument of the complex number z is equal to minus 2 minus 2i. So again, mod of z is equal to square root of x square plus y square. Here x is equal to minus 2 and y is equal to also minus 2. So it is equal to minus 2 square plus minus 2 square. So this is equal to 4 plus 4. So this is equal to 8, which is nothing but the 2 square root of 2. 2 into square root of 2. So this is what? Modulus of z, and argument of z can be obtained. The argument of z is equal to, now the x is negative, y is negative, so it lie in third quadrant here. So argument of z, principal argument, is minus pi plus tan inverse of mod of y by x. So it is equal to 2 by 2, that is 1. So minus pi plus tan inverse of 2 by 2 because of mod sign, which is equal to 1. So minus pi, and tan inverse 1 is equal to pi by 4. So the principal argument is what? Minus 3 pi by 4 is the principal argument of the given complex number. Next, example number 3. Find modulus and argument of the complex number z is equal to square root 3 minus I. So here the real part of z is equal to square root of 3 and imaginary part is equal to minus 1, and therefore modulus of z is equal to, the mod of z is equal to square root of x square, that is under root 3 bracket square, plus minus 1 square. So this is equal to root 3 square is 3 plus 1 is equal to under root of 4, which is equal to 2, and argument of z is equal to tan inverse of. Now here again we want to decide the location of the given complex number. Since x is positive and y is negative, that is it lie in fourth quadrant, so this is minus tan inverse of mod of y by x. So this is equal to minus tan inverse of y is what, 1, so because of mod sign it is 1 by root 3, so this is equal to minus pi by 6. So this is the principal argument of the given complex number. Now example number 2, if mod of z is equal to 1, given if mod of z is equal to 1 and argument of z is equal to theta, then show that 1 plus z 1 minus z is equal to I times cot theta by 2. Prove this. So the given mod of z is equal to 1 and argument of z is equal to what, theta. So the given mod of z is equal to 1, we know that the polar form of complex number z is equal to r e raised to I theta, that is r is what, mod of z. So what is given here, r is equal to 1, this is equal to e raised to I theta, and therefore now we want to show that the value of this term is equal to I times cot theta by 2. So we consider here LHS, and from LHS we are going to show that LHS is equal to what, RHS. So on the LHS it is 1 plus z divided by 1 minus z, which is equal to 1 plus e raised to I theta divided by 1 minus e raised to I theta, which is equal to, this is equal to 1 plus cos theta by using Euler formula I times sin theta divided by 1 minus cos theta plus I times sin theta. So this is equal to, now we know that the cos of a plus b is equal to cos a cos b minus sin a sin b, and therefore cos of theta can be written as cos of theta by 2 plus theta by 2. So this is equal to cos square theta by 2, since cos theta by 2 into cos theta by 2, here a is theta by 2, b is also theta by 2, minus sin square theta by 2. Similarly, the sin a plus b is equal to sin a cos b plus cos a sin b, and therefore sin theta by 2 plus theta by 2 is equal to sin theta by 2 cos theta by 2, cos theta by 2 sin theta by 2. So this is 2 times sin theta by 2 into cos theta by 2. So if you substitute this value, the value of cos theta is equal to cos square theta by 2 minus sin square theta by 2, and sin theta is equal to, this is nothing but the sin theta, is equal to 2 times sin theta into cos theta here. Okay, in this equation we get this is equal to 1 plus cos square, so this is equal to 1 plus cos theta is equal to cos square theta by 2 plus sin square theta by 2. Okay, sorry, minus, not plus. Minus sin square theta by 2. This is what, 1 plus cos theta value I times sin theta by 2. So what, plus times, so it is plus I times 2 times, that is 2I times sin theta by 2 cos theta by 2. Now divided by, in the denominator, 1 minus inside the bracket it is equal to what is given, cos theta by 2 plus I times sin theta by 2. So this is equal to cos theta plus I times sin theta. So cos theta is nothing but cos square theta by 2 minus sin square theta by 2 plus 2I times sin theta by 2 into cos theta by 2. Okay, this is the value of sin theta here, the value of sin theta. Now next, now 1 plus cos square theta by 2 is nothing but the sin square theta by 2, and it is equal to, sorry, not it is we know that as sin square theta plus cos square theta is equal to 1. So the 1 minus cos square theta, 1 minus sin square theta by 2 is nothing but the cos square theta by 2, but there is already 1 cos square theta by 2, so this is equal to 2 times cos square theta by 2 plus 2I times sin theta by 2 cos theta by 2, this whole divided by, now here also the 1 minus cos square theta by 2 is nothing but the sin square theta by 2, and this minus minus become plus, so this is equal to 2 times sin square theta by 2 plus 2I times sin theta by 2 into cos theta by 2. From this, if we take this 2 cos square theta by 2 outside, cos theta by 2 from the denominator, if we take 2 cos theta by 2 outside, and the numerator 2 cos theta by 2, and on the denominator take 2 times sin theta by 2 outside, then inside the bracket it is equal to cos theta by 2 plus I times sin theta by 2, and here it is equal to sin theta by 2 plus I times cos theta by 2. Now we know that this 2 will get cancelled here, and cos theta divided theta by 2 divided by sin theta by 2 is cot theta by 2. Sorry, cot theta by 2. And here since we cannot cancel the numerator and denominator, but if we make some arrangement here, we write this as we know that this cos square theta by 2 is nothing but, we can write this as minus I square cos theta by 2. We know that my I square is minus 1 because of minus sign, minus minus become plus I times sin theta by 2 divided by there is one correction, because of this minus sign this plus become minus, so we want to make this minus here, this is minus, and here also it is minus sign, so it is sin theta by 2 minus I times cos theta by 2, and from the numerator if we take minus I outside, that is equal to minus I times cot theta by 2, and on the numerator it is minus I times cos theta by 2 plus sin theta by 2, since we take I outside, and on the denominator also sin theta by 2 minus I times cos theta by 2. Now you can see here this term will get cancelled here, and answer is what, minus I times not minus, there is no need to take minus and outside, minus I outside, just take the plus I outside, so it is plus I times cot theta by 2. Okay, because what we want here, sin theta by 2 minus I times cos theta by 2, so if we take the minus sign outside, then here it is plus and here minus, so but we want here minus and here plus, so just we take the plus I outside, and we get it is equal to I times cot theta by 2, and it is nothing but right hand side, this is nothing but the right hand side of the given equation. So now next example number 3. make a sketch. Make a sketch. Make a sketch showing the set of all complex. Showing the set of all complex Z which satisfy the condition, the first condition, mod of twice Z plus 3 less than 1. So if we write here the value of Z as Z is equal to x plus iy, then we get the twice Z plus 3 is equal to 2 times x plus iy plus 3, which is nothing but twice x plus 2 iy plus 3, and this is nothing but the twice x plus 3 plus 2 iy. Okay, so here the real part is twice x plus 3 and imaginary part is 2y, and we know that the mod of Z is equal to the square root of real part square plus imaginary part square. So here the twice Z plus 3 less than 1 implies mod of twice x plus 3 plus 2y times I less than 1. So if you use this formula here, we get the real part square root of real part square, that is twice x plus 3 bracket square, and imaginary part square, which is less than 1. So what is the real? If you squaring on both sides, we get, this implies twice x plus 3 bracket square plus 2y bracket square less than 1, since the square of 1 is 1. Now we know that a plus b bracket square is 4x square plus 2 into 3 6 into 2 is 12x plus 9 plus 4y square is less than 1. If we take this 9 to this side, we get 4x square plus 12x plus 4y square is less than 1 minus 9, that is 8 minus 8, and if we divide both sides by 4, we get x square plus thrice x plus y square is less than minus 8 by 4. This is nothing but the minus 8, and again if we divide by 4, it is what? Minus 2. Now if we make the perfect square of this term, then we get it is equal to x square plus thrice x. For that, to make a perfect square, we divide the coefficient of x by 2 and make it square. So this is nothing but the 9 by 4 minus 9 by 4. We add and subtract 9 by 4 plus y square less than 2. So the solution of this term is nothing but the x plus 3 by 2 bracket square and plus y square less than, if we take this 9 by 4 to this side, it is 2 plus 9 by 4. So this is equal to, this is not minus 2, it is minus 2, not plus, minus 2 minus 2. So this is nothing but the x plus 3 by 2 bracket square plus y square less than minus 8 plus 9. So this is nothing but the 1 by 4, that is 1 by 2 square. So if we write this as x plus 3 by 2 bracket square, we can write this y square as y minus 0 bracket square less than 1 by 2 square. We know that this is a standard equation of circle. If we compare this equation with the general equation of circle, we get x plus h, x minus h bracket square plus y minus k bracket square is equal to r square. If you compare this equation, then here the center of this circle is minus 3 by 2 0 and radius is equal to 1 by 2. So if we draw the geometrical representation here, this is the real line, okay, and say x and y here, x y, say here minus 3 by 2, and we want to take a circle having radius is 1 by 2. Okay, if we use here, this is the again sorry, boundary points are not included here because it is less than, it is what, less than. So this is nothing but okay, the sketch of the given equation satisfying the condition. So here it is 1 by 2 minus 1 by 2. This is the circle having radius is what, 1 by 2. Now the next example, example number 2, again want to draw the sketch of the equation z mod of z plus 1 less than mod of z minus 1, mod of z plus 1 less than mod of z minus 1. So here again z, if we square on both sides, we get, if we square on both sides we get, first of all we want to replace this z by x. So this is nothing but z is equal to say x plus real x plus iy, then we get this is nothing but the x plus iy plus 1 and less than x plus iy minus 1. So this is equal to mod of x plus 1 plus iy less than x minus 1 plus iy. So it is what, if we square on both sides we get, this implies it is equal to square root of x plus 1 bracket square plus y square less than square root of x minus 1 bracket square plus y square. So if you square on both sides we get x plus 1 bracket square plus y square less than x minus 1 bracket square plus y square. So if we simplify this we get x square plus twice x plus 1 plus y square less than x square minus twice x plus 1 plus y square. So this y square, this x square 1 will get cancelled here. This implies twice x less than minus twice x. This implies twice x. If we take this minus twice x to this side, we get twice x plus twice x is less than 0, and this implies 4x is less than 0, and this implies x is less than 0. That is, the real part of z is less than 0. That is, x is less than 0. That is, this is the part where x is what, less than 0. X is what, less than 0. Okay. In this part our x is what, less than 0. So this is the sketch satisfying this condition. Now the next example number 4. Prove that cos 6 theta is equal to cos 6 raised to theta minus 15 cos raised to 4 theta sin square theta plus 15 cos square theta sin 4 theta sin raised to 4 theta minus sin 6 theta. Okay, and sin 6 theta is equal to 6 cos raised to 5 theta sin theta minus minus 20 cos cube theta sin cube theta plus 6 times cos theta sin raised to 5 theta. So now we are going to use De Morvis theorem here, as if we consider here cos theta plus I times sin theta raised to 6 using binomial theorem. This is equal to 6c0 cos theta cos 6 theta sin theta raised to 0 plus 6c1 cos 5 theta sin theta. Next, plus 6c2 cos 4 theta sin square theta plus 6c3 cos cube theta sin cube theta plus 6c4 cos square theta sin raised to 4 theta plus 6c5 cos theta sin 5 theta, and last 6c6 cos theta theta raised to 0, that is 1, and sin 6 theta. Now here the 6c0 is equal to 1. 6c0 is what? 1. If we use the calculator, then we get the value of 6c0 is 1. 6c1 is equal to 6. 6c2, that is 6 factorial divided by 2 factorial into 6 minus 2, 4 factorial. If you simplify this, 6c theta is equal to 15. 6 3 theta is equal to 20. This is equal to again 15. This is equal to 6c5 is equal to 6, and 6c6 is equal to what? 1. Here we use the formula NCR is equal to n factorial divided by r factorial n minus r factorial. So if we simplify this, we get cos 6 theta cos raised to 6 theta plus 6 cos 5 theta sin theta. Here is the one mistake, what is y here, the I times, so every times here is I, then here I square, that is I square, then here I cube, because A is cos theta and B is what? I times sin theta. Here I raised to 4, I raised to 5, and this is I raised to what? 6. So we know that the i's here 6i times 6i theta 6i times cos raised to 5 theta sin theta. Next this is equal the next term is 15 times the 6c2 15 times I square is minus 1, so minus 15 times cos 4 theta sin square theta. The next 6 3 theta I cube is I square into I, so it is minus I. This is equal to, okay, this is equal to minus 20 cos cube theta, minus 20 cos cube theta sin cube theta into I. The next term is I raised to 4. The I raised to 4 is I square into I square, that is minus 1 into minus 1 plus 1, so 15 cos square theta 15 cos square theta sin raised to 4 theta. The next, here it is 15. The next term is I raised to 5. So I raised to 5 is I raised to 4 into I, that is I times cos theta sin plus I times cos theta sin 5 theta. The next term 66 is equal to 66 is 1. So this is nothing but the sin 6 theta. I square is again minus 1. So this is equal to 66. What is it? Is 66 is 1. So sin 6 theta. Sin 6 theta. I raised to 6 is nothing but the I raised to 4 into I square. I raised to 4 is 1. I square is minus 1. So here the sign is what? Sign is minus 1. So now if we write the real and imaginary part in one bracket, we get this is equal to, what is the real part here? Real part is cos 6 theta, cos raised to 6 theta minus 15 cos raised to 4 theta sin square theta. This is the real part. This is what? A real part. This is real part. This is a real part. Again the next real part is 15 cos square theta plus into sin raised to 4 theta. 15 cos square theta sin raised to 4 theta. Again minus sin 6 theta. Minus sin 6 theta. And the imaginary part, if we write the imaginary part, then I times the first imaginary part is 6 cos raised to 5 theta, 6 cos raised to 5 theta sin theta. Then next the imaginary part is minus 20 times cos cube theta sin cube theta, minus 20 times cos cube theta sin cube theta. And the next imaginary part is I times cos theta plus sin 5 theta. So this is nothing but here is 6 is left, 6, sorry, because 6c5 is what? 6. 6c5 is what? 6. So this 6 times cos theta sin raised to 5 theta. Okay. Now this is what the right hand side. On the left hand side it is cos theta plus I times sin theta raised to 6. By using De Morvis theorem, this is nothing but the cos 6 theta plus I times sin 6 theta. This is what? This is nothing but the left hand side. Now if you equate the LHS and RHS, then this is the real part and the real part is equal to this term. Okay, and this is the imaginary part sin 6 theta and this is nothing but the sin 6 theta. And so if we write a real part, imaginary part, we get, and the answer is what? The cos 6 theta is equal to this and the sin 6 theta is equal to what? This. Thank you.